Hey guys, I'm Jeremy Gibbon Cantin and I will help you solving Laplace transform. Let's go. By definition, if you have a function f of t and then they ask you to find Laplace, you can denote it as L of what? You put this bracket or parentheses, all right? Or I prefer actually this f of s, all right? If it's f of t, it's going to be f of s, okay? If it's j of t, it's going to be big J of s, all right? Now, by definition, if you have f of t, you have to find the Laplace. It's going to give you f of s equal to what? Integral of from 0 to t goes like this, okay? T tend to infinity of what? Of that function f of t multiplied by e to the power minus s t dt. So for you to solve Laplace transform, you need to know integration. It's not any kind of integration, it's a defined type of integration where you have the limits, all right? And notice that it goes from 0 to t tend to infinity. But I want to go back a little bit about limits. I want to explain to you, if you have a function like this, limit when x tend to infinity, and then you have e to the power x, all right, what will be the answer? What will be the answer? Obviously, you put this value where there's x, it's going to give you like this, and then this is the same as e to the power infinity, it give you infinity. Remember, I don't know why people struggle here, because e is a value, it's a number, its value is 2.718 and dot dot dot, okay, something like that. Let me just quickly show you. When I press this and then e to the power 1, it gives you a number. I hope you can still see it, all right? It's a number, it's a constant. So a constant exponent, a constant, it's going to give you a big number, all right? So what we talk, infinity is a number that we cannot quantize, all right? It's a number that, it's a big number, okay? All right, now this one, but in our case we have limit e to the power minus x when we have something like this. Now look what happened. You're gonna have e to the power minus infinity, all right? But this is the same as e, all right? And this is 1 over e to the power infinity, and then this is the same as 1 over infinity, and 1 over infinity, it's 10 to 0. I want you to know that, okay? 1 divided by infinity, when you have a small number and then you divide it with a big number, that number goes close to infinity. So if you understand that, then we are safe. So every time we're going to have something, we will need to have minus in front of t, so that when we are replacing it, we can have 0. If you understand that, we are good to start. So first of all, we're gonna do Laplace using the first principle, or using the definition. What is the definition? Is this one: f of s equal to integral of 0 to t tend to infinity of that function f of t multiplied by e to the power minus s of t. These people were very smart. They put minus s of t, minus st. Very important. All right. So now let's quickly find or solve a equation here. For example, I'm just gonna do it here. For example, your f of t equal to 2, just for an example, right? They will never ask you a simple question like that. All right. So what will be your solution? Your solution will be f of s, okay, will be equal to integral from where? From 0 to infinity. Okay, well, t tend to infinity, right? Sorry. And then you take that value, that function, which is f of t, multiply by e to the power minus st dt. So this is so simple. What will be the answer? Okay, we can put this, all right, 0 t tend to infinity of what? E to the power minus t dt. And I want to tell you something. You must know integral. We have to know integration. When I have e to the power a x like this dx, this give me 1 divided by a e to the power x plus c, of course, okay? But I don't care about it right now. Please. So example, if I have e to the power 2 x dx, and then they tell me to integrate this, it's going to give me 1 over that 2, e to the power 2x plus c. All right. So if I have e to the power minus 1 over 2 x, okay, dx, it will give me what? It's gonna give me 1. This thing is a divided by 1 over 2, all right, e to the power 1 minus 1 over 2 e plus c. All right, to give you something like this, but then you have to simplify it. You know integration. So this, if a number divided by a fraction, it gives you that number multiplied by the inverse of the fraction. So here it's going to give you immediately minus 2 e to the power minus half x plus c. Right? So I wanted just you to know that part. If you know that part, we are good to go. So in our case, we have something like this. It's gonna give you what? This 2 is right there. Multiply by what? We take 1 divided by that term is minus s. All right. Okay. And then we do what? We multiply by e to the power minus st plus c. But here we have what we call the limit. So we're gonna put 0 and t tend to infinity here. All right. So what is this? Let me write it properly. You know that when we have you take the f of the bigger, all right, minus f of the lower limit. All right, so that's what we're gonna do. So here, remember our function is t, so we're gonna put t. We're gonna replace t by the bigger one, right? So we're gonna have what? 2 multiplied by 1 over s, okay, minus s e to the power minus s multiplied by the infinity, all right, minus, that's according to the formula that we are doing. We do the same thing now. We put the lower limit. It's going to give you 2 multiplied by 1 over minus s e to the power s times 0. All right, there we go. So we know already that when we have e to the power minus s, okay, s multiplied by infinity, it gives you infinity. all right? And then we already demonstrated that when we have e to the power x like this minus x, it tend to 0 because we have limit, we have infinity. So because the infinity is here and it's minus infinity, so this thing will become 0, all right? So this whole thing gonna become 0, but here we have e to the power minus minus s times 0. This one gives you 1. E to the power 0 give you 1. Anything to the power 0 give you 1. So we're gonna remain with 2 divided by minus s, and then this gives you 2 over s. All right, thank you for following this. And then let me quickly, now this is the type of question that can come. Let's say, okay, I'm gonna take it a small, let me take a, let's say you have f of t equal to let's say 2t, for example. All right, so we're gonna apply the same rule. We're gonna have 0 to infinity. Okay, I'm just gonna write infinity, it's okay. So I have 2t multiplied by e to the power minus st dt. So here it requires you to know what we call integration by part. You have to know it, okay? And we usually do what we call table method, and you can check my previous video on integration by part. You will see on YouTube integration by part, you will see on YouTube. Okay, so we have something like this. We're gonna do the table and we go as detail. Okay, so we have, sorry, okay, D is for differentiation, E is for exponential function, expo, T is for trigonometric function, A is for algebraic function, E is for inverse, and L is for log. Okay, so let's identify. We have two functions here. The first one is this one and the second one is this one. So we have exponential is right here. I have e to the power minus st, and then 2t is algebraic function is right here, 2t. So whatever come on top, it goes to integral. So this is sine, this is differentiation, this is integral. Whatever come to the top goes to integral. So what comes to the top is this one. It's e to the power minus st, and then we have 2t here. All right, first of all, you identify which one you're going to put in integral, and then you can put the other one on the differentiation side. Okay, now the rule of differentiation: when I have an algebraic function, you must differentiate until you get 0. If it's an algebraic function, you differentiate until you get 0. If you have a trig function, all right, you differentiate until it repeats. All right, for example, when you have cos, you differentiate, it's going to give you minus sine, and then you differentiate, it's going to give you again, you're going to come back to cos, it's going to be now minus cos blah blah blah. Okay, so in another term, when you have a trig function, you differentiate twice. Okay, and then when you have inverse or log function, you differentiate once. Log function, it's ln, it's log, and blah blah, you differentiate once. Algebraic, you differentiate until you get 0. Trigonometric, you differentiate until you get twice. It's repeat. Okay, so this one gonna give me 2, and this one integral, I told you it's gonna be 1 divided by minus s e to the power minus st. All right, so then the next is gonna be 0, and we're gonna do it again. It's gonna give me 1 divided by s squared e to the power minus st. All right, so the sign you just put plus minus plus. All right, it's alternate. Okay, so for you to copy this, you have to do this. You go palm, and then you bend over, palm, you bend over, and like this. Okay, so the last one you have to put integral sign. Okay, all right, so for me to write this answer, it's going to give me what? it's gonna give me, I have the integral 0 to infinity of 2t e to the power minus st dt. It's gonna give me what? It's gonna give me 2t multiplied by 1 over s, okay, e to the power minus st. All right, and then the next term is going minus 2 multiplied by this, going to minus 2 over s squared e to the power minus st. All right, that is, and the last term it's going to give me plus integral of 0 times what? It's going to give me 0. So this is what we have, but at the end we put our limits. Please go back, check the integral, how you solve the integral. All right, so if we put 0, if we put infinity here, because I have this one, I have minus st, it's going to give me 0. If I put infinity here again, it's going to give me 0. So the first part is give you 0, then you put minus. Okay, now we're putting this 0. When I put 0 here, it's going to give me 0. All right, if I put 0, this thing give me 0. All right, if I put 0 here, I'm going to have minus 2. This one going to give me 1. So minus 2 divided by s squared. Okay, all right, and this will be what? Minus times minus, going to give me positive 2 divided by s2. All right, so look at how simple and beautiful this thing is. And then you can always confirm with your table. All right, when you have a what, when you have a this type of function, okay, I have 2t, all right, exponent n is 1 here. This 2, it doesn't affect our stuff. We have like this, okay, this is what we have to deal with. So it's going to give you 2 multiply what is t, it's going to give you exponent is 1, it's going to 1 factorial divide by what? S n, which is 1 plus 1, 1 plus 1, which is going to be 2. So you're going to have something like 2 multiplied by 1 s squared, and then which is exactly your answer. All right, so but we're going to see the table later on. Okay, so let's continue. Now this question can come. You have, if they give you f of t equal to e to the power, let's say through 3t, for example. This is a very good question. This can come. Now look what will happen. You have to find the Laplace. Okay, it's going to give you integral from 0 to infinity, and you have e to the power 3t multiplied by e to the power minus st. This is very good question. What do you do here? Look, as I told you, at some point we're gonna substitute the upper limit, which is infinity. So we have to make sure that the exponent should be something, okay, minus something t. That's the goal. Now look, when you have the same base, you add the what? The exponent. Okay, let's go it slowly. We're gonna go slowly here. I have 0 infinity, and then I have same base. It's gonna give me 3t. I'm adding, it's gonna be minus st. All right, good. And then we have dt. Okay, well, someone can say, no, let me put it like this. I can put t in a, I can factorize. So I'm gonna have 3 minus s t. All right, I can write it like this. Okay, e to the power this, right? But this will get you into trouble, because when you replace, you're gonna have e to the power infinity, and then if you have e to the power infinity, you cannot do anything. So you must write it in a way whereby you have minus something and t. So here we have to put minus. We can factorize minus. If I factorize minus, everything becomes so simple. Look at this. I put minus outside, then I'm gonna have s here, and I'm gonna have minus 3 here, t. With this, oh, Things are so simple and easy. And we know that when I'm integrating this, it's going to give 1 divided by that a. All right, so e to the power that thing. All right, now we have our limit. We can put 0 and t tend to infinity. Please, you must factorize. You must have minus something t. Please, if you don't have it, you're gonna struggle. You're not gonna get the answer. All right, so here let's replace the lower limit, the upper limit first. When you put infinity here, this thing becomes 0, so we don't care. We put 0 minus. Now when you put 0, now we're replacing 0, it's going to be 0. Here it's going to give you e to the power 0, which is 1. So I'm going to have this s minus 3. Isn't that cool? And then this, when you have minus can give you this positive s minus 3. Isn't that cool? Please, I want you to know that when you have exponential function, make sure that you have minus in front. If you don't have that minus, you're not gonna get the answer, because when you put infinity here, infinity times this thing gonna give you infinity. So, and then you're gonna get e to the power infinity, which is infinity. You're gonna have infinity you cannot solve. Okay, you're gonna have infinity minus something else, which gonna give you infinity if you don't get your answer. Please. All right, I'm gonna stop this video and I'm gonna do a second video where I'm gonna deal with unit step. Thank you.